Math 3, Semester 2, Mastery Exam Review, Power Standard 4. Simplify the following expressions. Write your final answer in radical form. Part A. When you do not see a little number right here, this little number is called an index. When you do not see one, it's understood that it's an invisible 2, which means it's a square root. So, on A, the square root of 25 is 5. And then as far as variables go, you take the exponent under the radical and you divide it by whatever the index is. So since the index is an invisible 2, 2 divided by 2 is 1. So and it would be x to the invisible 1, which is just x. And then for the y's, 9 divided by 2 does not divide. So I would want to break down y to the 9th. So what I do is I try the first exponent lower than 9. So I'll try 8. And then I'll check and see if 8 is divisible by whatever my index is. So 8 divided by 2, that does divide out evenly. So I want to split y to the 9th into y to the 8th and y to the invisible 1. So the 8 divided by 2 is 4. So that's going to come out from under the square root. And then the y to the first stays underneath the square root. And I don't put the invisible 1 on my final answer. So then that would be it for that one. Part B, the little 3 is the index. So as far as the cubed root of negative 64 goes, we're looking for a number that when you multiply it by itself 3 times, you get negative 64. So that would be negative 4. And I'm actually going to show my work slightly differently on this problem. I'm going to break each term down into its separate cubed root. So cubed root of negative 64 is going to work out just fine. Cubed root of x squared is going to have to stay under the cubed root because the 2 is smaller than the 3. So basically 2 divided by 3 is a decimal. It's 0.6 repeated, and it's a decimal less than 1, so we're not going to be able to simplify that. Cubed root of y to the 6th, we should be able to simplify right away because 6 divided by 3 is 2. And then that last one in the back, we're going to need to split up z to the 13th because 13 divided by 3 is a decimal. So try the next exponent down. So 12. 12 divided by 3 is 4. That does divide evenly. So I'm going to split my z to the 13th into z to the 12th and z to the invisible 1. These two numbers, the 12 and the 1, have to add up to whatever the original exponent was. So it's not necessarily always a 1 as the other number. It's just whatever two numbers add up to the original exponent. From here, we can simplify almost all of these. So cubed root of negative 64 is negative 4. Cubed root of x squared cannot be simplified, so we're just going to leave it cubed root of x squared for now. 6 divided by 3 is 2, so that simplifies evenly, so it comes out from under the radical. For the z's, 12 divided by 3 is 4, so that comes out from under the radical. And then the last one, you can't simplify, so it just stays underneath. At the very end of the problem, all of the terms that are not under the radical should come out in the front. So negative 4y squared z to the 4th. And then everything that's underneath the radical should stay under the radical. So cubed root x squared z. And then that should be our answer. For part C, the cubed root of 4 cannot be simplified because there are no perfect cube factors of 4, and 4 is not a perfect cube. The next term, 3 divided by 3, is going to simplify down to 1, so it'll be x to the first. We'll simplify that in just a moment. Cubed root of y, we're not going to be able to simplify. And then cubed root of z to the 5th, we're going to need to break down that z to the 5th because 5 divided by 3 is a decimal. So try the next exponent down. So try 4. 4 divided by 3 is also a decimal. So try the next exponent down, 3. 3 divided by 3 does work. So I'm going to split my z to the 5th into z to the 3rd and z squared. And that 3 and that 2 have to add up to that 5. So that's how I knew that it was z squared as the leftover. And then now we just do a bunch of simplifying. So I cannot simplify that. 3 divided by 3 is 1, so it's x to the invisible 1. I cannot simplify cubed root y. Cubed root of z to the 3rd is just z, because 3 divided by 3 would be an invisible 1 on the exponent. And then I cannot simplify the cubed root of z squared. Anything not under the radical should come out in the front, so the x and the z. And then anything under the radical should stay under the radical, so the 4yz squared. And then that is the answer. For letter D, there's no little index, so it's understood that it's a square root. It's an invisible 2 as the index. So 18 is not a perfect square, but it can be broken down into a perfect square factor and then whatever's left over. So when you're talking perfect squares, you're talking about things like 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on and so forth. So those are perfect squares. So I didn't write down 9. I wrote down 3. And that's the one we need. 1, 2, 3, 4, 5. So the largest perfect square factor of 18 is 9. So we're going to split 18 into square root 9 times square root 2. The square root of x to the 4th I'm going to leave alone because that will simplify evenly since 4 divided by 2 is 2. And then the y to the 11th I'm going to want to split into something that works because 11 divided by 2 is a decimal. So I want to try the next exponent down. So 10. 10 divided by 2 is 5, so that works. So I'm going to split y to the 11th into y to the 10th and y to the 1, or to the 1st. So 10 plus 1 is 11. Those two exponents have to add up to the 11. And now let's go back and simplify the ones that simplify. So square root of 9 is 3. Square root 2 stays the same. Square root of x to the 4th is x squared, because you're doing 4 divided by 2 is 2. Square root of y to the 10th is y to the 5th, because you're doing 10 divided by 2. And then square root of y stays square root y. So the 3, the x squared, and the y to the 5th are out in the front, and then square root 2y. Number 3. I think you'll find this a lot easier than number 1. So all they want you to do is practice evaluating functions. So we give you a bunch of functions, and then we say find these different values. So g of negative 3 literally means take negative 3, plug it in to the g function, and wherever I see an x, put in a negative 3 in parentheses, and then you're just going to simplify following order of operations. So I have to do exponents first. So negative 3 squared is negative 3 times negative 3, which is positive 9. But then that negative sign right there drags down. And then negative 9 plus 4 is negative 5, and done. That would be the answer for part A. Part B, we want to get f of 4. So I'm going to take 4. I'm going to plug it in for x, like that. And then I'm going to simplify. So absolute value of negative 1, and the absolute value of negative 1 is positive 1. And then negative 2 times 1 is negative 2, and then we get negative 7. For part C, we want h of negative 1. So h of negative 1 equals 2 times parentheses negative 1 to the 3rd minus absolute value of 1 minus 5 times negative 1. So wherever I saw an x, I put in a negative 1. Following order of operations, I want to do the exponent first. at least for that first term, and then I'll get to the absolute value in just a second. So -1 times -1 times -1 is -1. And then inside the absolute value bars, do your multiplication. -5 times -1 is +5. Back up in the front, 2 times -1 is -2. Inside my absolute value bars, 1 plus 5 is 6. Absolute value of 6 is 6. And then -2 minus 8 is -8. So h of -1 equals -8. For 3, we want to solve for y at each equation below, show all work. So these are basically those inverse problems. It's just that we started the problem for you. So those were those problems where you would have to switch x and y and then solve for y. We're just starting at the solve for y part of the problem, since this is Power Standard 4. So here is my y. I want to get y all by itself by doing order of operations backwards. So I'm going to add 10 on both sides to get rid of the subtraction. I'm going to divide by 3 on both sides to cancel out multiplication. And then that should be it. So then we have x plus 10 over 3 equals y. For part B, I want to isolate the radical first before I try to get rid of it. So I want to add 9 to both sides of the equation to get rid of that -9 in the back. And then in order to undo something that has a root, you just raise it up to the exponent that matches the index. So the index is that little 3, so I have to raise it up to the third power. And whatever I do to one side of the equation, I have to do to the other side to keep it balanced. So the whole point of raising it up to the third power is to cancel out the cubed root. So I'm just left with the y plus 2. And then -2, -2, and then we get x plus 9 in parentheses to the third -2 equals y, and that's it. Last one, -8 minus 8, x minus 8 equals 3y squared. Undo multiplication by doing division. X minus 8 divided by 3 equals y squared. So in order to undo an exponent, you have to take the corresponding root. So since the exponent is a 2, I'm going to do a square root. If the exponent had been a 5, I would do a 5th root. So I'd have to put a little 5 right here. But since it's a square root, I don't need to put the little 5. Now, technically, when we introduce a square root or a 4th root or a 6th root or an 8th root, really any root with an even number, you need to add in a plus minus symbol. So this is actually plus or minus square root x minus 8 all over 3. And that actually is the answer. If the little index, so that number I just, here, let me do a different color. So this number right here that I just put the little pink dot on, if that number is odd, then you don't have to add that plus minus symbol right there. And then that is it.